Hello, physics electric current. The question is a 10-meter length of wire consists of 5 meter of copper followed by 5 meter of aluminium. So this is a wire which is 10 meter in length. So this is 10 meter in length, and the 5 meter is copper, and the rest is 5 meter is aluminium. And is both diameter is 1 millimeter. So this diameter is d is equal to 1 millimeter. The voltage difference across is 85 millivolt. So voltage is equal to 85 millivolt, which is equal to 0.085 volt. The question is, what is the total resistance, sum of the two? So total resistance we have to find. So resistance we have to find. What is the current? We have to find I. And what is the voltage across? So voltage across we have to find across copper and aluminium. So we have to find this one. So there are two things. One is copper. Another one is aluminium. So resistance we have to find. So resistance R is equal to resistivity rho length over area. So area is equal to pi r square, or pi, you can write down 2r by 2, which is, and 2r is equal to d. So pi d square by 4 or 1 over area is equal to reciprocal 4 pi d square. So this will be equal to 4 rho L pi d square. So resistance is equal to 4 rho L over pi d square. So L is 5 meter, 5 meter, d diameter is same, only resistivity is different. So here is a copper and here is aluminium. So if you substitute the values of the resistivity and others, you can see the if 4 into copper have a lower resistivity, 1.68 into 10 to the power minus 4 ohm meter, and the length is 5 meter, and pi and diameter is 1 millimeter, 1 to 10 power minus 3 meter whole square. So similarly, this is our copper. Similarly, our aluminium is equal to 4 into resistivity 265, 2.65 into 10 to the power minus 4 ohm meter multiplied by 5 meter divided by pi into diameter 1 millimeter 10 to the power minus 3 meter whole square. And this resistance is equal to 0.1069 ohm. Copper or aluminium is equal to 0.168 or 1687. So 1687 ohm. So the total resistance R total is equal to R copper plus R aluminium. So this is equal to 0.1069 plus 1687, and this is equal to 0.2756. So our total is approximately equal to 0.28 ohm. So this is the resistance. So this is A. B part is a current. So these are in series, so the same current will flow. It's like this is a three road of 3 lane, and then is a 1 lane, and the flow will be restricted to this one. So whatever is the how many traffic is there, so traffic resist is this one, so it will be same. So the current V is equal to IR. V is equal to IR. So the current is equal to V over R total. So V is given, which is 85 volt, which is equal to 0.085 volt over this one, 0.2756 ohm. And this will give us the current, which is equal to 0.308 amp. So the current is equal to 0.31 amp approximately. So this is the current. So this is a second part. Now the third part. Third part is the individual voltage. Voltage. So the copper and aluminum. So voltage on copper, V is equal to IR, I total, which is this one, into R of copper. And similarly, voltage of aluminum is equal to I into R of aluminum. So this one give us this answer. So we'll use this the value of the current here. So 0.308 amp multiplied by the resistance of copper, which is this one. So the copper is 0.1069 ohm. So this will give this voltage, which is equal to 0 0.033 volt. So this is voltage of the copper and voltage of aluminium. Aluminium is VAL is equal to the current, which is 0.0308 amp multiplied by resistance. So resistance of this aluminium is this one. So this one is equal to 0.1687 ohm, and this will give us the value, which is 0.052 volt. So V aluminium. So this is aluminium, this is copper. So finally, if you present these answers, copper, aluminium, and first one is resistance in ohm. It is 0.1069, and it is 0.1687, and current in amp, same, and which is equal to 0.28, and the voltage, it is equal to 0.033 33 and 0.052. This aluminium had more resistance, but on the other hand, aluminium have more voltage. This is slightly more resistance. There should be more voltage, but it is something slightly different. So copper have a less resistance, and voltage is also less. So this is the result of this calculation. So this is the question. So this is a beautiful question and good calculations.